Well, hello, class.
Hello. Start talking.
Oh, I guess I better start talking then. Find k so that the differential equation, here it is, dx, or 2x minus y times sine of x times y plus k times y to the fourth dx equals 20 xy cubed plus x times sine of xy dy equals 0 is exact. So what do we have to do? Well, you take a partial of this one with respect to y, right? You get a little 0 from this. Partial of this with respect to y, that will require the product rule here. So I guess you can see xy times the negative xy, negative from this negative sign, negative xy cosine of xy minus, now partial of this with respect to y is just going to be 1, so minus sine of xy, normally it'd be plus, but this minus makes the whole quantity negative, plus partial of this with respect to y is just 4ky cubed. Now when we take a partial of this, this part, if it's going to wind up anything decent, this part has to match up with this part, and I think it does. It almost looked like it didn't for a minute because I had an extra parentheses that I didn't need, but yeah, this part, see, we got that lining up perfectly, and of course, we'd have to take the derivative of this with respect to x as a product rule, but I think it's guaranteed that that part will come out nice, because the part that's dangerous is the negative 20y squared has to be equal to 4k, or sorry, negative 20y cubed has to be equal to 4ky cubed, so therefore k equals negative 5. That one was almost too easy.
Yeah.
Right, okay, so one last problem. Determine a function n of xy so that the differential equation is exact. And here's what we have: y to the 1/2, x to the negative 1/2. Could call that the square root of the quantity y over x if you wanted. But anyway, plus x over x squared plus y dx plus n of xy dy equals 0. Well, wow. We don't get much of a break here, do we? Well, we know the integral of this we can do with respect to x. And of course this is just a constant with respect to x, so the integral of x to the negative 1/2, add 1 to the power, x to the positive 1/2, so, and then divide by the power, which is dividing by 1/2, which is like multiplying by 2. So there's 2, x to the 1/2, y to the 1/2 for this part, and then we also need to integrate this with respect to x. And I think it wouldn't be too hard for you to see if you let u equal x squared plus y, then du equals 2x dx, and we have x dx already in the numerator. So quick u substitution should show you why that's 1/2 ln of absolute value of x squared plus y, plus some constant function h of y, that is constant function of y that would be like a constant since we integrated with respect to x. But this indeed might be our function f of xy that we want to set equal to c, but that doesn't tell us what this n is. In order to find out what this n is, we would have to take the derivative of this function, all of this function, with respect to y, to see what the total differential is. Well, differentiating this with respect to y, you get 1/2 y to the negative 1/2. That half and this 2 will cancel out, so you get x to the 1/2 y to the negative 1/2. And then differentiating this with respect to y is just, since that's just ln of y plus a constant when you're differentiating with respect to y, derivative of ln of y is 1 over y. So it's 1 over that x squared plus y. The half gives us this 2 in the denominator, plus h prime of y for whatever this h is. And so we actually have an infinite number of possible answers for this, but let's pick the simplest possible. Let's pick h such that h prime of y equals 0. And so then our function n of xy would be x to the 1/2 y to the negative 1/2 plus 1/2 times quantity x squared plus y. And note that any function h of y could be added, but we want to keep things as simple as possible.